Welcome back. Hopefully you've had a little bit of a play around with creating your own NumPy arrays, but if not, that's okay, because in this section, what we're going to do now is have a look at how we can create NumPy arrays. And so in the previous section or video, we went through creating some of our own arrays, A2, A3, A1, and we learned about different attributes that these arrays had, but it was very tedious typing out all of these different numbers. So let's have a look at some easier ways. First, to begin with, we'll just see it again, just in case. So sample array, how we did it the first time. mp.array, and we passed it a list of numbers. Wonderful. Oh, we'll go here, and just so it prints out, we'll have sample array here. So this is going to give us a one-dimensional NumPy array with the elements 1, 2, and 3 in it. So if we check this array's data type, there we go. Beautiful. Okay, now, for example, what if we wanted to create a NumPy array that was already filled for us? What if we didn't want to pass anything here? Let's have a look at how you could do that. Let's make one called ones, and you go mp1s. Actually, what does np.ones? What do you think that will be? Well, I've got a little trick I can show you to get a little preview of this. Let's hit Shift and Tab whilst we're inside the brackets. Oh, what have we got here? Signature np.ones shape docstring. Return a new array of given shape and type filled with ones. Beautiful. So what Shift and Tab does, remember we'll exit out of here, we'll come back into this. If we type in any kind of function, so np dot something brackets, if we push Shift and Tab while we're inside here, what that's going to tell Jupyter to do is open up the function's docstring. So this gives us information. So this information here comes straight from the NumPy documentation. This is going to tell us what this function does. Return a new array of given shape and type filled with ones. Let's see here, parameters shape, int or sequence of ints, e.g. 2, 3. Let's use that example, 2, 3. Shift and enter. Okay, what does this look like? Ones. Ah, an array filled with ones. That's exactly what it said. Shift and Tab, return a new array of given shape and type filled with ones. Now we haven't put in type here, but we have given it shape. Okay, let's have a look here. Ones.dtype. That's dtype float. So if we use ones, pretty sure float is the default data type. Now you could probably find that. That's a little challenge for you, is to find out what the default data type is by reading through the docstring. Let's keep going. If we checked type of ones, we can see that it's our beautiful and favorite data type is nd array. Wonderful. Now let's have a look. What if we wanted another array, but not with ones, we wanted one with zeros? mp, let's see, mp zeros. Does it have this? Ah, docstring. Return a new array of given shape and type filled with zeros. Okay, let's do the same again. np.zeros, zeros. Wonderful. Okay. Now you might be thinking, Daniel, why would you want ones? Why would you want zeros? Well, in that case, you could imagine zeros as kind of like a placeholder array. Maybe in machine learning, you want to fill an array with some initial data or that data you don't know yet. So you create the zeros just to work out the shapes of data you're working with. So before you even implement any data, you could make sure that your shapes lined up by using arrays filled with zeros. But let's keep going. Let's see how we could make a few more different kinds of arrays. Let's go range array equals np.arange. Let's see, Shift and Tab, that's what we're practicing at the moment. Return evenly spaced values within a given interval. Start, stop, step. Okay, let's have a look. Start number, stop number, step number. Well, let's try it. If in doubt, always try. 0, 10, 2. Now, if this is going to be start, stop, step, what do we think that this will return? Let's have a look. Range array. Ah, so it's going to start at 0, 0. It's going to stop at 10, but it's going to step up by 2. 0, 2, 4, 6, 8. Wonderful. Let's keep pushing forward. Let's go random array. What if we didn't know what numbers? We just want NumPy to just fill an array full of random information for us. np.random. Let's do rand int. Shift and tab. Let's practice. Docstring rand low, high, size. Return random integers from low to high, exclusive. Okay, return integers from the discrete uniform distribution of the specified d-type parameters, low, int or array of ints, high, int or array like of ints, optional, size. Okay, so let's go 0, 10, size 3 by 5. What do you think this will return? Let's have a look. Random array. Size is not defined. What have we done wrong here? We haven't set size equal. Wonderful. So what this has done, we will see what the actual docstring. Return random integers from low, this is our low, 0, low, inclusive to high, exclusive, 10, of size 3 by 5. So now, if we go random array dot size, we have 15, and we want random array dot shape 3, 5. Wonderful. And we can see that in our array, the low is 0 and the high is 10. Wonderful. Let's see one more way of creating random arrays. Random.random. NumPy has a fair few different ways of creating random arrays. You don't need to know them all. There we go. So random.random, what does this do? Shift tab. Return random floats in the half open interval 0, 1. So this is going to return, and it takes a parameter size. Let's save this to random array 2. And then we want to show it, random array 2. Wonderful. Random array 2. Let's check the shape. Shape, there we go. Shape is 5 and 3. Wonderful. So that means it's always rows, then columns. So 5 rows, 3 columns. 1, 2, 3, 4, 5. 3 columns. And if we check this, it's going to be between the intervals 0 and 1. Wonderful. Got a random array. And let's see one more. So we want random array 3. Now this is where NumPy can get a bit confusing, is that these dot rand or random and dot random 5, 3 do very similar things. Random. We go to Shift Tab. We can see what the docstring says here. Return values in a given shape. So that's what I've done. Passed D0 and D1. So dimension 0 is 5 and dimension 1 is 3. So remember, always goes dimension 0, dimension 1. If we go back to the anatomy of our NumPy array, axis 0 is the same as dimension 0, which is the row here, and axis 1 is the same as dimension 1, which is the columns here. Wonderful. Now, the thing you should know about the random numbers in NumPy is they aren't actually random. They're set with something called a random seed. NumPy.random seed. What could this mean? They're pseudo-random numbers. Pseudo-random numbers. We'll have a look at this in the next video, but this is an important concept to remember going forward, is that when NumPy generates random numbers, they're actually pseudo-random numbers. So take a quick break, try practice creating some of your own random arrays using the .random or randint. Have a look at the docstrings by pressing Shift Tab, and then in the next video, we'll have a look at np.random seed and see how we can generate some non-random random numbers.